8M2, Lesson 3, Translating Lines. In this lesson, we are going to talk about specifically the translation of lines. The homework adds a little bit of Lesson 1 and Lesson 2 back into it, so we'll also do some homework help for Lesson 3. So let's get on with it. Let's learn about translating lines. And we need to go to our sketchpad. There it is. All right, let's get going. Okay, so let's remind ourselves how we talk about lines. Lines are defined by, if you have any 2 points in space on a plane, you can create a single line out of those 2 points. So for example, I've created here, I've shown you point X and a point Y, and we've drawn a line through those 2 points. Likewise, if I drew a line, a point here and a point here, point A and B, there is exactly one line that I could draw through those 2 points. And let's see if I can kind of, well, I'm not going to do a great job here, but boom, well, no, boom. You know, if this line were straight, you can see that there's only one line. You cannot draw 2 lines through 2 distinct points, only one, in exactly one line. Okay, so let's get on with it. Now let's talk about translating lines. We are going to translate lines the same way that we translated. And remember, what translation is kind of like, it's like moving or sliding. There's no rotation and no flipping or no mirroring. We cannot do these things. We can only move or slide. So remember, when we took a triangle and we translated it along a vector, we moved each point, we identified the 3 points on the triangle, and we moved them the distance and the length of this vector. So we, to here, to here, and to whatever, to here, and we translated our triangle. Okay, we of course we're going to do it with exact measurements, but I just wanted to kind of remind you how we translated. And remember, when you translate using this strategy, you will never, it will always, a triangle that's in this orientation, it will always end up in that same orientation. Okay, very good. Now let's talk about translating lines. We're going to do that in the exact same manner that we translated anything else. So the way that we're going to translate a line, identify 2 points on the line and translate each along the given vector, because we always translate along a vector, and okay, we translate each along the vector to and let's see, that's 1. 2, we'll label our new points, and 3, we'll draw our line, draw our translated line. Okay, translate each along the vector, label our new point, and then we're going to draw our line. So we have our line XY. We can also identify it. This is how we talk about lines. A line XY, notice we have a symbol, the line symbol, on top of our 2 points. These 2 points are the 2 points that identify the line because they both live on the line, and this is our symbol on top that identifies that we are indeed talking about a line and not a line segment and not a vector, not array, not an angle. Okay, so we're going to translate this line along vector AB, which I will draw for you here in a second, along vector AB. Okay, so we're going to take AB, we're going to call this AB. Let me draw that in a different color just to help identify it. And we'll do this. I will go to my, okay, now I'll go to my line tool and make a nice straight line so I don't confuse anyone. And then we will draw that translation. Okay, well, that wasn't very neat, was it? Let's, anyway, yeah, we'll call that neat enough. Okay, so we're going to, here, maybe I'll draw it a little bit more crisply. Okay, so now let's take this piece of, let's see if we can take it like that. Uh-oh, I don't want to get that AB piece in there. There we go. We'll copy it, and we're going to translate each of our points using our vector. Okay, so that's the first thing we're doing. We're going to translate each along the given vector. So we take the 2 points, x and y, which we're going to remap, or we're going to map. Now I'm going to draw this new line. Let's draw it in red. So let's put our new points right here and right here. Okay, now remember how we label our new points. We can either call them the translation of x and the translation of y, but we're going to shy away from that terminology, and we're going to use our prime technology because or our prime methodology. So we'll call that x prime, and we'll call this y prime. So those are our two translated points, and now we're almost done. We simply have to draw our new line, and voila, we have our new line, XY. And to make sure that we understand it's a line, I'll put my arrows on each side. And we have our line X prime, Y prime. And there's our translated line. Interesting to note. What can you say about line XY and line X prime, Y prime? And we're going to talk more about this on the next slide. But the interesting thing that you can say is you can say, well, ask the question, will these lines ever intersect? And the answer is no, they're not going to intersect. And so we can say that line XY is parallel. Watch all this terminology, all these symbols. So line XY, I'm going to write it out. Line XY, this is how you'd say it in English. Line XY is parallel to line X prime, Y prime. Okay. All right, that's point number one, how we translate lines. Moving on. I'm going to ask you a different question. Now, can you draw, the question we're going to ask ourselves is, if we take a line and we translate it, what kind of outcomes can we get? We'll call this line, we'll call this one XY also. Now, the question is, if we translate a line along a vector, what is relationship between original line and the translated line. And we can think about it. Okay, so we'll take, just look at any given vector. Let's take another vector. We'll take one that looks like this. And we'll call this one, you know, XY. No, we can't call it XY. We'll call this one again. We'll call it AB. Now, if we translate, and let's just look at some other vectors. I mean, let's look at one that goes straight up and down, or straight down. You know, this has got to be a straight line. You know, call that one CD. Take one that goes kind of up and to the left. Well, we'll use our tool and we'll make it perfect. And we'll call that one EF. Let's look at this. If we take our point X and Y and we translate it along this guy, are we going to end up with what kind of, let's look at like all these different examples. And I think we're going to learn something pretty quick about these lines. So we're going to take AB. Whoops. There's A. And then there's AB. And we translate along that guy. We're going to end up with a certain kind of line again. Let's make these lines, let's make these translated lines, let's make them like kind of like blue. And then we'll make our pen color, we'll put our little arrows on it. Interesting. And now let's translate along CD. Let's make this one in, we'll make this one in yellow. And you're going to start to notice something about any one of these given lines. And now let's translate along FE. Well, we're running out of colors. We'll put this one in, whoops. We'll make this one in we'll make that translated line in green. How about we'll make this one green? Okay, so that one's going to be green. And what do you notice about, what do we notice? What do we notice about all these lines? I encourage you, you're right if you said they are parallel. And I encourage you to try to find a vector that would not make a parallel translation. make or yield a parallel translation? And you can't. The answer is if you translate any vector, any line along a vector, you will end up with a parallel line, actually with one exception. And let's look at that exception right now. So let's put a happy cat here because we've definitely learned something important. This is a key point, is that the key point, of course, is, when you translate a line along a vector, what is the relationship? The relationship is the line are parallel. That's the key learning. Now, with one exception, and let's do that one right now. Okay, let's open one more page, and let's make a line. And we make them all parallel just because they're horizontal, because they're a little bit easier to deal with. We'll deal with another line here in a second that's maybe not so, maybe doesn't start this way in the homework help. You'll see. Now watch what happens if I take my line XY and I'm going to translate it. I'm going to pick a custom line that looks like this. Okay, so there's my custom line AB, or my custom vector AB. Now if I translate this along XY along AB, watch what happens. I think maybe some of you can even see it. So I'm going to take my X and I'm going to translate it along this line, and I'm going to take my Y point and I'm going to translate it along this line. And watch what happens. I'm going to make these two new lines that are, or these two points. I take my translated points. This is X prime and Y prime. And when I draw my line, lo and behold, what is true? What is true? They are on top of each other. XY goes infinitely long left and right, and so does X prime, Y prime. So line XY, well, let's just say it equals X prime, Y prime. They are equal. So when I translate a line along a vector, the translated line is either A, the same line as the original, or B, parallel to the original. And that, that's hopefully something you can play around with. This one should be pretty easy to see. If you translate a line along a vector that's the same, that's parallel to that line, you're going to keep points. Those points are always going to be on the line. And so when you draw your final line, you're going to end up with the same line. And going back to the prior example, you should, if you play with it enough, you'll see that you will always end up with parallel lines if you have vectors that any vector that is not parallel to the original line. Okay, let's look at one more point that they make that's pretty key in the chapter, and that's this. If I have a line, so here, we'll make one that's not, we have a line like this, X, Y, and we have a point P that is not on the line. And this is a key point that will come back later in the chapter, I think, and later in geometry. But how many lines can you draw through this point that are parallel to X, Y? Let's draw one of them. And the way that we can do that is we can take here, I'm gonna cheat doing a technique that I know how to use, drawing So I'm going to take this line. Make a copy of it here. So I'm going to make I kind of used a cheater technique that I know how to use. It's not really a cheater technique. It's quite a nice algebraic technique. But I'm going to make the line parallel. And I'll get rid of this. So I just made a line that's parallel to xy that goes through point P. Now the question is how many lines parallel to line xy go through point P. And you did this exercise in class. This is the question. And the answer is only one. I think your teacher tried to trick you in class. And if you look at it quick, there's no lines parallel to xy. I mean, you know, one that comes like, oh, that's not parallel. One that goes like this is not parallel. Even one that kind of goes like that, those are not going to be parallel. There's only one line going through point P parallel to xy. So that's a point that's made in the chapter that you need to memorize or need to know. It becomes very important later on in geometry. But let's move on and let's go on to homework helpers. Okay, so in this homework help, I'm going to ask you a few questions. This should, if you can do this one, you should be able to do the rest of the homework. And so we're going to say A, we're going to translate, we want to translate a triangle, translate triangle ABC, and this is A, B, C, along XY. That's the first thing. And the second thing we're going to do is we're going to label the new triangle using prime notation. And then C, we're going to say, what do you know about the sides of triangle ABC and your new triangle? And then D, I'll ask you the question after we do C. Okay, so here we go. So we're going to translate triangle ABC along this vector. And notice, let's notice this vector here. In this vector, we go down 3. We go down 3. Down 3 and over 1. Right? We go down 3 from 1, 2, 3, and we go over 1. Oh, from 3.5 to 4.5, and we go down from 1 to 4. So we go down 3 and over 1. That's our vector. But we're just gonna do it the old-fashioned way, the way that we've been learning how to do it. But you're gonna notice that these points go down 3 and over 1 as I move them along this vector. And let's watch how that happens. Let's watch that happen. So here's our first one. Here's our second one. And here's our third one. Okay, so let's do that. So here's our new points. We're going to make our new points. We're going to do them in yellow. Okay, so our new point is right here. Our other new point is right here. And our other new point is right here. And now let's just kind of look at that real quick. I'm going to get rid of these old lines. Get rid of the old, just getting rid of these old lines to kind of hide them, get them out of the way. We can even move this vector over here. Let's just move this vector out of the, whoops, our X and our Y. Okay, and there's our new triangle. And let's just draw our new triangle so we can see it. And you can see that it's pretty much the same triangle. It's just translated. Now now we've translated it. Now the second thing that we want to do is we want to label it. So this is our new corner of this triangle. We're going to call that one A prime. We're using our prime notation. And this is the one that corresponds to B, the ones that when we translated point B, and when we translated point C, we have C prime. So our new triangle is triangle A prime, B prime, C prime, and it's right there. So now the question is, what do you know about the sides of triangle ABC and our new triangle? What do we know about those sides? We remember that when we translate, and you pause and let you do this yourself. Okay, I'm assuming you're back. You know, line segments are the same length. So we know that AC equals A prime C prime. And we know that AB equals A prime B prime. And we know that BC is equal to B prime C prime. That's what we know when we translate. And on D, I'm going to ask you a new question. What do you know about angle ACB and angle A prime, C prime, B prime? So in other words, ACB and A prime, C prime, B prime. So I'll pause, stop the video, and make your guess. And I'll give you the answer right now. And the answer is angle ACB is equal to angle, well, the measure of angle ABC is equal to the measure of angle A prime, C prime, B prime. Okay, and that is worthy of a happy cat. Happy cat. We'll get a happy cat for each of these guys, for each problem that you got right. Okay, very good. We are done here. We are done here. Sorry. Thank you. And we'll be back with lesson 4 tomorrow. Let me know if you like it. Give me a like, please. And if you want to subscribe, and it'll make your life easier. When new things come up, it'll just automatically slide into your email for you, and you'll be aware of those when they happen. All right, goodbye. I hope you have a great evening or a great weekend, whatever's upcoming for you. And hopefully all of your math is awesome and fun.